Hello, this is our second lesson about Young's double slit experiment problem. So last lesson we solved one problem. Today we want to go through a couple of more problems about that. The first one, that is example 1, was in the previous video. This example 2, what's the distance on screen between adjacent maxima near the center of interference pattern? So just I quickly go through content again. So if you remember when we say double slit, we have slit 1 and 2. If I name this one S1, this one is 2, and this one was our screen. And this distance from slits and screen was L, yes. And then if we have a point like here, let's say this one is central point, let's say this one is M. So this one is M plus 1. Whatever this M is the next one. We are talking about two consecutive ones. And then because they said it's adjacent maxima, so we have two maxima. One maxima at this point, one maxima at this point. And if you remember, we had a formula for finding maxima from last video. If you remember, it was M lambda divided by D equal Y divided by L. That M is the order of this, M lambda or M plus 1 lambda. Lambda is the wavelength of the light. D is the distance between two slits from here to here is D, and L is the distance from slits to the screen. And Y is the distance between central bright point and next one. For example, if I want to calculate this for M plus 1, this is my Y M plus 1, and this part is YM. Okay, right now, what's the distance on the screen between adjacent maxima? So something that the question asks us, they ask for this part between two adjacent maxima. What's this one? We don't have any formula to calculate this one directly, but we have the formula to find Ym plus 1 and Ym. Why I'm saying Ym plus 1 and Ym? Because they say adjacent maxima. So if I name one is Ym, the other one is Ym plus 1. So I write the equation for every single one. So for M plus 1, I can write M plus 1 lambda divided by D is equal Ym plus 1 divided by L. As a result, Ym plus 1 is something that I want to find, because if I have Ym plus 1 and Ym, then I just deduct Ym from this one to find X. That is something the question asked me. So Ym plus 1 equal M plus 1 lambda times L divided by D. And also I need to find Ym. So I write Ym here, Ym. So how I can calculate it, I say M lambda divided by D equal Ym divided by L. As a result, Ym equal M lambda times L divided by D. Right now, the only thing that I need to do, I need to find what's the answer for Ym plus 1 minus Ym. And then it means that M plus 1 lambda L divided by D minus M lambda L D. If I deduct these two, just I show the workout. If you're not really strong in math, help you. So it equal M lambda L minus lambda L minus M lambda L. As a result, this one with this one, 0. Sorry, this one was plus, just I made a mistake. Okay, so it's equal lambda L D. So what's the distance between two consecutive bright parts between any two of these, this one and next one and this one? And next one, the only thing that we need just is equal to lambda L divided by D. This is lambda, this wavelength, L is this distance, and D is the distance between these two here. And the unit definitely is meter. Okay, right now let's go through one actual question. What's the distance on a screen between second and third maxima near the center? Okay, right now they are talking about second and third. Again, what we need to do, immediately we write the formula. Y divided by N. And then for second one, I write it like 2 lambda divided by D equal Y for second divided by N. And for the third one, just I write 3 lambda D equal Y third divided by D. And then here as a result, Y2 is equal 2 lambda L divided by D. And here Y3 equal 3 lambda D, sorry, here was L. 3 lambda L divided by D. So as a result, Y3 minus Y2 is equal 3 lambda L D minus 2 lambda L D. Again, lambda L D is something that we just calculated in previous question. Then the only thing that we need to do, we need to substitute number. Just remember, always distance and length should be in meter. So your lambda, the wavelength is 546 nanometer. 546 nanometer times 10 to the power minus 9, because we want this in meter. And then L, let's separate. So this one is RD, and this one is RL, that is in centimeter. That definitely we need to convert it to meter by dividing by 100. So 0.5, and the millimeter we need to convert it to meter by dividing this by 1000. That becomes 12 times 10 to the power of minus 5. Right now just we need to do some calculation. Then it's equal. So it's become equal, I just calculated that. So it becomes 25 divided, sorry, times by 10 to the power of minus 4 meter. Thank you for watching.